Let's do question 1. Here we have the definite integral from 0 to 1, 1 over x plus 1 minus 1 over x plus 2 dx. So first we find the antiderivative of this expression, that is 1 over x plus 1. The antiderivative of this expression is natural logarithm of x plus 1. Now the antiderivative of 1 over x plus 1 is natural logarithm of x plus 2. And this must be evaluated from 0 to 1. And so this we can rewrite this as we can combine these two logarithms using property of logarithms. That is, we can write this as natural logarithm of x plus 1 over x plus 2. We put this inside the absolute value, and this must be evaluated from 0 to 1. So now let's apply the upper limit to 1. And so when we do that, we have a natural logarithm of 1 plus 1. We replace x by 1, and this becomes 1 plus 2 minus, now we apply the lower limit for x, so therefore this becomes 0 plus 1 divided by 0 plus 2. And so this gives a natural logarithm of 1 plus 1 is 2 divided by 3 minus natural logarithm of 1 by 2. Now once again we can use the property of logarithm to combine these two logarithms. That is, log a minus log b equals log of a by b, natural logarithm. So therefore this becomes a natural logarithm of here a expression is 2/3 divided by b expression is 1/2. So let's simplify this. This equals a natural logarithm of 2/3. We then multiply by the reciprocal of the denominator, which is 2 by 1. And so this gives a natural logarithm of 4/3. So this is the result of the definite integral. In fact, we can give is a decimal approximation by plugging this into the calculator. And so when we do that, we get approximately 0.2877, and this is rounded to 4 decimal places. So the result of this definite integral is this expression, or its decimal equivalent is 0.2877. Let's do question 2. So here we have the definite integral of cosine 3x cosine 4x dx from x equal to pi by 6 to pi by 2. These are the limits of x. So first we can rewrite this product function as a sum function using the product to sum identity. That is cosine A cosine B. This is product of cosine, and this equals half of cosine A plus B plus cosine A minus B. This basically is the product to sum identity. So we are going to use this identity. So I'm going to replace A by 3x. So therefore this becomes cosine 3x, and B by 4x. So it becomes cosine 4x. And this equals half of cosine A plus B. This one is A and this one is B. So 3x plus 4x equals 7x, plus we then have cosine of 3x minus 4x is negative x. And now we can use the identity, that is cosine of a negative angle equals cosine of positive angle. That is cosine negative x equals cosine x. And so therefore we can replace this cosine of negative x as just a cosine of positive x. And so we are going to replace this cosine 3x, cosine 4x as this expression. So let's do that. And so this gives the definite integral from pi by 6 to pi by 2. We then put half of cosine 7x plus cosine x dx. Now in the next step, we can factor the half from the inside of the integral. So we put it in front of the integral. So it gets multiplied with 1 by 2 of the definite integral from pi by 6 to pi by 2. We then have the expression cosine of 7x plus cosine of x dx. Now we should find the antiderivative of cosine 7x and cosine 6x and then apply the limits. So therefore this equals a half of the antiderivative of cosine 7x is sine 7x divided by 7. We can determine this by using the U substitution method, that is cosine 7x dx. Here we make the substitution 7x equals u. So therefore 7 dx equals du. And this means dx equals du over 7. So therefore this expression becomes cosine of 7x equal to u, cosine u. And then dx is replaced as du by 7. We factor the 1 by 7 out of the integral and then write du. And now the antiderivative of cosine u is I'm sorry, I'm going to put 7 here. So this one is 1 by 7th. The antiderivative of cosine u is sine u and replace u by 7x. So therefore, this is the antiderivative of cosine of 7x. That's what I have written here. Then we put plus. Now the antiderivative of cosine x is, we know from the standard integration formula, it is sine x. And this must be evaluated from pi by 6 to pi by 2. So first we apply the upper limit, and so therefore this becomes, we will have the constant 1 by 2, and then this will become, replace x by pi by 2, and so this becomes a sine of 7 times of pi by 2. So it's basically sine 7 pi by 2 divided by 7 plus replace x by pi by 2. It is sine of pi by 2. Now we have to subtract by applying the lower limit. So we put minus and then replace x by pi by 6. So therefore it is a sine of 7 times of pi by 6 divided by 7 plus sine pi by 6. Close this bracket for the multiplier 1 by 2. Now we have to evaluate the sine of 7 pi by 2. And this basically equals negative 1. So this is negative 1 over 7 plus sine pi by 2 is positive 1 minus this one is sine of 7 pi by 6, which basically equals negative half. When we rewrite this sine 7 pi by 6 as sum of some reference angle, that is pi by 6. So this is divided by 7 plus sine pi by 6 is half. Let's evaluate this. So this equals half times, this basically is 1 minus 1 by 7, or otherwise 7 by 7 minus 1 by 7, which equals 6 by 7. We then put minus, this is negative 1 by 2 times 7 is negative 114 plus 1 by 2. So let's evaluate this. This one is negative 114. So to make this as a common denominator, multiply and divide by 7. So this will be 7 by 14. And so this equals positive 6 by 14. So let's put here. So therefore, in the next step, I write this as a half times of, we have 6 by 7 minus, and this is basically 6 by 14. So we have a half times 6 by 7 minus 6 by 14. Let's make this as a common denominator. So we multiply and divide this fraction by 2. So therefore this will become half of 12 by 14 minus 6 by 14 equals 12 minus 6 is 6 by 14. So this one is half of 6 by 14. divide this 6 by 2, this goes 3 times. So it's basically 3 by 14. So in terms of fraction, the result of this integral is 3 by 14. We can also give it a decimal approximation, that is this one approximated to 0.2142 rounded to 4 decimal places. This is the approximate value of 3 by 14. Let's do question 3. So here we find the integral of dx over 4x times square root of x squared minus 16. You can solve this integral by substitution, trigonometric substitution method. So here I'm going to substitute x equals 4 times secant theta. And this means dx, we find the derivative. This equals 4 times the derivative of secant theta is secant theta tangent theta and then d theta. And let's also evaluate this expression if x equals 4 secant theta. So we first square this. This gives x squared equals 16 secant squared theta. We then subtract 16 from both sides so that we get x squared minus 16, and this equals 16 secant squared theta minus 16. And here we can factor the 16 and this becomes secant squared theta minus 1. And we must be knowing the identity, that is 1 plus tangent squared theta. This equals secant squared theta. This is one of the Pythagorean identity. And from this, if we subtract 1 from both sides, we get tangent squared theta. This equals secant squared theta minus 1. So we can now see that secant squared theta can be replaced as tangent squared theta. So let's do it here. This becomes 16 times of tangent squared theta. That is, we now replace this expression as 16 times of tangent squared theta. We will also write 4x. So this gives 4x equals, we multiply both sides by 4, 16 secant theta. So now let's rewrite our original integral in terms of theta. That is, I'm going to copy the original integral, dx divided by 4x times of square root of x squared minus 16. So let me first replace for dx. Dx is replaced by this expression, that is 4 secant theta tangent theta d theta. So this is 4 secant theta tangent theta d theta, and this is over. Replace 4x by 16 secant theta. So this becomes 16 times of secant theta, and then the square root of replace x squared minus 16 by 16 times of tangent square theta. So this is 16 times of tangent square theta. Now let's simplify this and evaluate this integral. So here we have, we can cancel this secant theta and then this secant theta. And then we have 4 divides into 16 as 1/4, which I factor the 1/4, and then we put the integral of tangent theta d theta. This is divided by 16. The square root of 16 times of tangent square theta is basically 4 times of the square root of tangent square theta is tan theta. So this one is tangent theta. Now we see that we can cancel this tangent theta with this tangent theta, and we are left with 1/4. So we already have 1/4 in front of the integral. So these two gets multiplied, which gives 1 by 16 the integral of just d theta. The integral of d theta, which is equivalent to integral of 1 d theta, this equals theta. So I put 1 by 16 times of theta. Now we can replace the value of theta from the substitution that we made. That is 4 times x equals 4 secant theta. And this means we can solve for theta from this one. but we are going to make some rearrangements. That is, we did the substitution x equals 4 secant theta. Let's square both sides. This equals 16 secant square theta. And we replace secant square theta using the Pythagorean identity. That is, secant square theta is basically equal to 1 plus tangent square theta. So therefore, this becomes x squared equals 16 times 1 plus tangent square theta. Now dividing both sides by 16, we get x squared by 16 equals 1 plus tangent square theta. We subtract 1 from both sides, which leaves us x squared by 16 minus 1 equals tangent square theta. Let's simplify this left side expression. So this simplifies to x squared by 16. We write this one as 16 by 16 equals tangent square theta. And so this equals, we now have a common denominator, x squared by 16 divided by 16 equals tangent square theta. Taking square root on both sides, we get tangent theta. This equals x squared minus 16. The square root divided by square root of 16 is 4. So I write 4 here, and this equals square root of tangent square theta is tangent theta. And so we solve for theta from this equation. So here we have to take tangent inverse on both sides. Therefore, we get the expression for theta. This equals tangent inverse of x squared minus 16. This is under the square root divided by 4. We put this as part of this tangent inverse. So you can put this inside the bracket. So this basically is the theta value. That is, we have written the theta in terms of our arctan function. So now we can replace this theta here. We will also have to put the constant of integral c once we integrate. So I put plus c. And so this equals 1 by 16 times the theta is tangent inverse square root of x squared minus 16 by 4. We can write this tangent inverse as arctan also. So it is arctan uh, x squared minus 16. This is under the root divided by 4. So this is the expression of arctan. So it's basically 1 by 16 times arctan x squared minus 16 by 4. Otherwise, we can also rewrite this as arctan square root of x squared minus 16. This is divided by 4, and this is over 16. So this is the result of the given integral. Let's evaluate this integral in question 4. So we are going to evaluate this using the u substitution method. That is, we can let 2x equals u. And so this gives 2 dx. This equals du, or otherwise dx equals du by 2. I specifically substituted 2x equal to u because we can rewrite this as 2x quantity square. So that would be our first step. So I write this now. So dx divided by square root of 1 minus 2x quantity square. So after this first step, we do this substitution. That is 2x equals u, and therefore we get dx equals du by 2. So let's do the substitution over here. And so therefore this becomes dx is replaced as du over 2, and this is divided by 1 minus 2x is replaced as u. So it becomes 1 minus u squared under the root. Let's put this in simple form. So here we have a 1 by 2 which can be factored out of the integral. So it becomes 1 by 2 integral of du divided by 1 minus u squared. And now the antiderivative of 1 divided by 1 minus u squared Here we are using this antiderivative formula, that is 1 minus x squared. Its antiderivative is sine inverse of x plus the constant of integral. The sine inverse of x also written as arc sine x plus constant c. And so therefore this equals a half of, we can write this as arc sine u plus the constant of integral c. Now we do the back substitution for u, that is 2x. So therefore this equals half arc sine of 2x plus the constant of integral c. And so this is the result of the given integral.